So guys, yes. So now the question is, when we have a non-technical background, or when we have a background where we simply work on Excel files. So is data science for us? Is it like, can we do it, or we gonna face a real uphill challenge to learn the technologies? Because as we move forward, we will have three challenges which we'll have to face moving forward. On the web, if you Google about probably about being a data scientist, um, so so the data scientist job responsibilities typically involves, as you might also know, about cleaning the data, right? So his responsibility is also to model the data, plus also to put a lot of intelligent algorithms in the model so that we are successfully able to predict or also successfully able to gauge where the business is likely to move. Um, could be in terms of higher revenues getting from business process. It could be a process optimization. It could be a production inventory management. It could be a profitability solutions in finance. It could be fraud detection in an insurance company, and many more. It could be it could be useful in medical trials um, for evolution of new drugs and the new impact it might have on the society. So there are many factors which involve building up the model and then finally recommending the model about something. Now, do you think by just learning the training or by working on certain tools, we'll be able to do that with just a couple of years of experience? Um, Typically, not. So a data scientist on working on a reporting system or working on an aggregated data or working on an ETL system may not qualify to be a data scientist with just mere couple of years of experience. Uh, uh, it would take, almost 2 decades. I mean, if I'm not too high, at least, uh, at least a decade. We need to spend in the industry, on the technologies, on the business problems, in order to call one a data scientist. So we'll proceed with the presentation and we'll see what we have. So what do we know about data science? Okay, now we have two words in this. We have data and we have science. So can we link together? So science is basically the scientific approach to something, scientific approach to something using the data we have for kind of descriptive analytics. It could be an inferential analytics. It could be a predictive analytics, or it could be simply a prescriptive analytics. Okay, now these are all stages to move forward and graduate from learning from one place to another. But typically, the role should start from the descriptive data. It should start first from aggregating the data, understanding the data, what the data holds for you, what is the problem statement that you can find the solution in the data for. So that is what we should start with. So we'll talk about that in detail, and I want this session to be very interactive. So I'll keep a close watch. I'll keep a close watch on the questions panel, and I would really appreciate if you can just put down on your questions if you have any for me. So moving forward in this part, on the agenda today, it says how statisticians have automated themselves as data scientists. Guys, in today's session, I have a news for you. Not sure if you would take it in a positive way. Um, you may hear people talking about statistics is something which is not a mandatory to be when you're into data science. Now, with my experience, statistics is the only thing that can qualify you to be a perfect data scientist. So so the first thing is, should I learn the statistics? Should I learn the mathematics involved in statistics? Or I should start learning a programming language, which would make me a data scientist specialist? Or I should get into some kind of a functional training when I am educated about the business and the business process so that I can further instruct to improvise a particular business process. That's absolutely correct. So these are the three things which you would require all the time when we're talking about data science, when we're talking about building algorithms, when we are talking about automating things, when we're talking about problem solving, and also uh, about what data science has bring to us, what kind of a value addition it has bring to us in terms of increasing the revenue, in terms of increasing productivity, in terms of analyzing a situation better, in terms of intelligence services to detect fraud. Okay, so how statisticians have automated themselves as data scientists. This is something which we see in the coming slides. But I'm sure, first, we need to understand what is data. So data is actually information. It is information. It is qualitative. It is quantitative. I'm sure that some folks might be aware of how the data is represented. It is represented in the form of an ordinal data, or it could be represented in the form of a nominal data, or it could be a ratio, or it could simply be a score. In any of the cases, we are talking about data which is measurable. So we are talking about data which is measurable means it is quantitative. When we talk about the genre of a particular film, when we talk about the gender, when we talk about the color of an eye, when we talk about the dimensions of any product, that's when we're talking about the qualitative information. So we need to make a fine distinction when we are studying data, whether we are studying a continuous quantitative data, or we are studying something the discrete qualitative data is what we're aiming at. So data is the raw state, and when we tune the data uh, to give us inference, and that's where it becomes an information. And further down to the information, it becomes the knowledge. So that's what we have in our next slide. There is a question by Durga Someshwara. The question is, what is the relation between artificial intelligence and machine learning? Now, machine learning is a part of artificial intelligence. Okay, in order to build a complete AI solution, ML has to be in that. Some part of ML has to be in that. It could be a mix of the various types of machine learning algorithms to build one particular artificial intelligence. The artificial intelligence could be simply a driverless car. Okay, so in order to build seamlessly a driverless car, we need to use supervised, unsupervised machine learning algorithms. We could use other modeling techniques, other models, cognitive services, text services, voice speaking services, speech recognition, all these cognitive services are also involved in building artificial intelligence. A robot is an artificial intelligence. It has a brain which works on machine learning. So just like the human brain. Now, I mean, human brain when we are infants, we hardly understand things, right? Because we are not trained uh, to understand things. Probably when we are too young, we don't recognize that this is a television or this is a wall, or we should not walk on edges. Probably it might be fatal. So when we hear from the people around us that we should not walk on the edge, it could be fatal for life. Or this is a television, so our brain is also being trained on regular basis. So artificial intelligence is nothing that we are training the intelligence of a computer artificially by using various machine learning models, and that could be supervised, unsupervised models. We'll talk about those models moving forward in the presentation. So this presentation talks about how do we manage it in an organized and a meaningful way. So the first thing what we collect is data. Okay, so the data could be in the form of samples, it could be in the form of surveys, or it could be in the form of transactions for a retail store. Okay, or it could be someone who's approaching at a petrol pump station or a fuel station or some public place, asking certain questions about your background and or maybe your maybe email addresses and telephone numbers to send you some promotions or give you some kind of a gift voucher, etc. So that is also data collection um, for various target companies to promote their marketing products. So the data, what is data? It's a facts and statistics collected together, like name, place, and things. So the example could be, may I have your name and the contact number? So that is simply the data. I haven't transformed that into a knowledge. I haven't transformed that into an intelligence. What the data next step becomes is an information. So facts provided or learned about something or someone. So hello, my name is Sam, and you may contact me on. So that's the information which I have. That okay, this person is a male, and his name is Sam, and his contact or coordinates to reach is X, Y, Z. How that information becomes a knowledge, that the facts, information, awareness acquired through experience. That Sam is 36 years old and he lives in the western part of the state. So if he lives into the western part of the state, probably he is quite rich because that part of that location is 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 of more of wealthier people. That is one of the knowledge which I can infer from that. And the intelligence could be that Sam is 36 years old and he's certainly interested in building a financial portfolio. So probably this would be a good information for financial companies or probably financial institutions to take Sam as one of the marketing lead to probably upsell their financial products. Now, all this information, when it starts flowing from data to the intelligence, that's where this data science comes here. Because the data which we collect may not be sanitized, the data which we collect may not have appropriate principal components, or it may have components which are kind of an extra in the analysis, which needs to be imputed. There could be some null values. There could be some values which are not needed into the record sets of the data. So that needs to be imputed. So all this process needs data cleaning, data sanitization, etc. So for that also we require specialized skills to understand the data, to model the data so that we may clean the data. And finally, once the sanitized data is available to us, we can push that into our model so that we are able to get some inference out of the data we have. Looking at the side, so how statisticians have automated themselves as data scientists. Now, this is a loop, according to me, with my experience, I feel. Because when I started the analytics experience, I was not a statistician. I mean, in fact, I'm still not a statistician. I have not done my bachelor in science and statistics, neither have done masters in science and statistics. But yes, statistics is a subject which I'm, it's like it started long back, but still few things are still there which I need to work on it. So I'm sure statistics has no end. It is not a finite subject. It is a subject which has infinite observations. It has infinite techniques and methods to and approaches to solve a specific business problem as far as data is concerned. So in case if we are not statisticians, we should not worry. At least we can work on the statistics which is useful for analyzing the data. Now, what are the key topics in statistics we should be aware of? So the key topics likely to be the basic distributions in the data. Now, this is the first topic in any statistics book or in any university textbooks which we will see. We will have the distributions of the data. Then we talk about the frequency distributions. Probability is something which is very important when we talk about data science. Then we talk about the algebraic, that is the linear algebra. That is something which is required. If you have a lot of time, you can also study about logarithms in mathematics, and if possible, you can also study about derivatives if that's okay with you or if that's your interest. But the distributions in the data and the probability distributions is something which is very important when we talk about data science, because we are talking about probabilities. So what is the probability that this particular product will sell online under certain conditions or circumstances? what is the probability that Mahesh Bhupathi is likely to play a match scheduled on a particular day when the temperature is going to be 35 degrees, etc. So we always talk about in terms of probabilities. So that is a very important topic which we should not run away. So what this slide talks about, that is it required to be a statistician if you're talking about data scientists, or is it, or the statisticians should worry about that they should start learning technologies so that they may qualify to call themselves as data scientists. Now the argument is endless because statisticians carry a different set of knowledge base, and the technology professionals carry knowledge at a different. Statisticians may not be aware of the computational capabilities. They may not be hands-on with the computational approach of processing the data. But the technology specialist can process the data using the modern technologies and in a faster manner. So what is the way out to become a data scientist? The way out for statisticians is to work on technology, and for technology professionals to work on statistics. That's the only way out. So looking at this slide, we talk about that statisticians generally deal with small amount of number, and they've been dealing with hardly some 500 rows or 1,000 rows or probably 5,000 or 10,000 records. But in today's generation, we're talking about lakhs and lakhs and billions of records coming into a database table or in a particular model. You're talking about big data analytics, so that carries a separate expertise to work on to work on these technologies, and working on statistics as far as sampling the data is concerned, finding the probabilities in the data is concerned, doing the mean testing of the data between the populations in the population. So doing some kind of a t-test or a z-test or a chi-square, or at least a basic Poisson or chi-square regression or linear regression is something we should be capable of doing it. Now we can pick any technology to implement the approach of statistics in data science. We can use basic as an Excel to do the job. We can use R programming if you are quite proficient in and if you have an interest in programming. You can also use Python for that matter, and there are many other tools available in the market to do the job. But the thing is, even if you train yourself as a technology professional, are you still aware of what to do when the data set is given to you? Are you capable enough to get the inference from the data by using these technologies? Are you capable of creating a model which will likely to predict something out of the given data set? If that happens, then definitely we're talking about being a data scientist. There are some questions on the panel. I'd like to address that. Harishankar Dash says, how to decide best fit data set for a business problem in terms of quantities and data quality. Okay, not a bad question, Hari. So the question comes is how to decide the best fit data set for a business problem. I mean, this is something that's where the expertise or the blend of statistics and the technology comes out here, Hari. You're talking in terms of quantities and data quality. So data quality is something needs to be addressed before you push or pump the training data set into the model, or before you could use the data set for the model. You need to make sure that the data has a proper sanitized treated data. It should have the quality in that. So that's the first step. Second step is your quantities. Now, quantities, I believe you're talking about the number of variables which we should consider in the analysis. Now, before we do that, there's a topic to answer this question, Harishankar. There's a topic in statistics called as factor analysis. Using the factor analysis, using the correlation of the ratios between the variables, we do factor modeling. We use different types of rotations in that. Uh, we use Varimax rotations, even in R, even in SPSS, even in Python, we use rotations like Varimax rotations. And based on those rotations, we can derive that how many principal components we should be selecting into the model. What is the contribution of each variable, whether the variable is significantly contributing into the model performance or in the likely output of the model, or it's not performing. So if it's not performing, the factor analysis drops the variable from the analysis, and that's how you can actually decrease your data set. So PCA, principal component analysis, is a very important factor, Harishankar. I hope that answers the question. Mohammed Yassi, in data science without much of technical knowledge, analysis on simple tools like Excel. Yeah, thanks, Hari. Mohammed, there is a question by Mohammed Yassin. He says data science without much of technical knowledge, analysis on simple tools like Excel. That's right, Mohammed. So, in case if you are not very familiar with technical tools, or if you are not wanting to be comfortable with programming language, then you can simply choose Excel. So, if you know, there is a tab in Excel by itself called as data analysis. So when you go to your Excel document, under the data tools, we have an option called as data analysis. In case if you're not able to see, you can definitely put that as an add-on pack in your Excel under options. So when you click on the data analysis tab, we have basic, statistical, descriptive statistics application functions out there under the data analysis pack in Excel. So basic t-test, z-test, z-score, testing for normality, uh, and various types of regression techniques are available in the data analysis pack. So you can start exploring from that side in case if you're not wanting to to do a lot of programming. Oh, all right. And so, what is a data scientist? I think what we see on the screen is a bit on that. So, I'll quickly go through this. Now, many statisticians think that data science is about analyzing data, but it is more than that. Data science also involves implementing algorithms that process data automatically to provide automated predictions. Uh, um, if you ask me, I think a bit differently. It's not about many statisticians think that data science is about analyzing data. They are already aware that data science is actually talking about predictions. Data science is actually talking about inferential statistics. But what they lack or what they do not know is how to deal with the data when the data volume is extremely high. If you talk from a statistician's perspective, he's still talking about dealing with small Excel files, or he's still talking about dealing the files which are in the CSV format with hardly 5,000 or 10,000 records in that. But now we are not talking about that. We are talking about the data which is voluminous in nature. Okay, so when that volume of data is wanting to be supplied into a predictive model, that's where it requires a lot of steps. Uh, the data has to go through many steps in order to transform itself into a logical model, which is worth processing or worth pushing into the model framework. Now, how do we do that? Now, that's where the technology skills comes into picture. So, statisticians needs to bend a bit on the data cleaning side as well, or a data preparation side as well. If they incline towards these technologies, then I'm sure that they'll be able to write a big data Hadoop program by themselves, and they can get the data by themselves, and then they can create the model also on top of it. So how do we do this? When we receive the data, it's in the most raw format. It could be the tweets coming out from the Twitter API. It could be the YouTube comments given on a specific set of videos. So if you want to deal with this kind of data, you could also be wanting to find out about the emails or sensitive information is being passed over email. Uh, so you can definitely work on text analytics. You can work on image analytics for digital image processing. So if I upload an image, my model should automatically classify that image, whether this image is for a specific animal, or it is for a ship, or is it a vehicle, or is it a human, or is it a bird, etc. So in order to do that, we need to let the data go and follow the stages. And the stages goes like we need to extract the data, we need to transform, we need to load the data into a storage space, and then we need to process the data. Now, extraction, I'm sure everyone is aware what extraction does. Extraction is extracting the data from the source. Transform is basically converting the data from one state to another. Okay, I have transformed a string data type to a date, let's say, or I have replaced the null values with the mean of that variable. A loading is to store the data, and processing is basically to process the data. Now, what are the possibilities to process the data? Um, the processing could be uh, splitting the variables. The processing could be concatenating the variables, etc. There is another slide. There is another image on the right hand side. So if you see the data capturing, harvesting, storing, and preparation. So there are various stages to that. So we have data extraction from the unstructured data source from the CRM. Then we take it to the staging database. We load it into a data warehouse. And then finally, we create the data match. So guys, there's one more layer which I would like to add out here. Excuse me. Uh, we can see this ODS out there, right? That is operational data store. But there is one layer now in this ETL which talks about the Hadoop or the big data system. Okay, so what happens? The big data systems consume the data from the source systems like CRM, ERP, or be it that matter, be it images, be it social media tweets, etc., in the unstructured format. So with this, all the data is absorbed by the big data system based on its power of distributed computing or distributed processing. The big data system processes the data in much faster time period and loads the data into the staging database or directly into the data warehouse. And from the data warehouse, various reports can be distributed. Aggregated data can be transferred to various departments, and also the data from the warehouse can be used by data scientists to get inference from the historic data. Okay, now there is another question by Mohammed again. It says, for this, we need to have statistical knowledge. Yes, Mohammed, in order to become a data scientist, you need to have statistical knowledge. Any impact of age, different experience will impact career in data science? I think there's no age to learn new things. Different experience will impact career in data science. That purely depends on your interest, Mohammed. So if you are able to pursue it for a very long time, and I'm sure it will definitely not impact. Uh, there's a question by Prithvi. I'm from management and production. Can I be successful learning that? Can I successfully learn data science? Uh, of course, Prithvi, you can do that provided you learn it with interest. Saurabh Mathur, do we need to know SQL Server in depth and use queries? Saurabh, uh, uh, I would highly motivate and encourage you to work on SQL queries and SQL servers because that's a very good approach to understand the descriptives of the data. So continue with the SQL queries. Harishankar, big data is more of ELT model. That's correct, Harishankar. Big data is more of the extraction and loading the data into the Hadoop file system, and then running the MapReduce or Spark programs to transform the data and then finally store it. So you're right. So Hadoop is automation in data science. So as we know, now data science is usually this area is it's so popular because of its automation capabilities. I mean, that's what everyone would like in a if a manufacturing company would like to have. The first thing is to reduce cost in any business. What we not need to do first thing is to reduce the cost. Could be the renting experience of the facilities which we have put into the business. It could be the operational expenses, or it could be the employee expenses. I think employee expenses and salaries to employees is something which costs a lot to the company. So that's why when the company experience a dip in the revenue or experience a fiscal loss, the first thing what they do is they'll they kind of ask employees to leave, especially people who are on high pay scales. So so everyone wants to create things which is automated, right? We don't want to do the same jobs again and again by the same folks. Now, what if the laborers who are there in a manufacturing plant or the technicians who are on the shop floor of a manufacturing plant? What if we don't need them? What if we don't need so many developers? So just imagine down the line 7 years, we may not require developers, we may not require Java specialists, we may not require .NET specialists. Probably an era would come that with just few clicks that you just need to define uh, the the MVC controller models in .NET. Let's say you can just define that using a workflow. You can just define that this is the main method of the program, and this is the later section of the program. This is the exception try catch handling section. If you can just define this using a workflow and can simply click on a button wherein the computer will generate the entire code for you. So we don't require developers out there, right? We simply require people who know how to join the blocks together so that we are able to create a better program. And I'm sure that will happen down the line 7 8 years. So we would not need developers sitting on the desk and writing codes to create some specific application. Everything is going to happen through the API moving forward. So when we are talking about automation, so automation could be, if we have a look on the picture on the right hand side. So again, the same things. We have the data collection, data cleaning, feature generation and selection, algorithm selection, parameter tuning. Now, feature generation and selection is basically choosing the variables we are interested into the data set. And algorithm selection could be, if I want to do cluster, then am I talking about hierarchical clustering, or I'm talking about k-means clustering? If I'm choosing a specific model, then the model is an unsupervised machine learning model or it is a supervised machine learning model. Those are the decisions onto the algorithm selection side. Parameter tuning is typically after choosing the algorithm when we create the model, then that time we actually tune the model so that the model accuracy increases, and some post processing validation also we do. So if you look at the automating picture down in the picture in the circles, so what we do with the data is first we do the data understanding, we do the business understanding. Now this is a very generic steps. You talk about implementing a BI solution, you talk about implementing an ETL solution, you talk about any project management solution. Any project management will have these stages in it. Okay, so the stage is to understand the business, which is the first thing. Second is to understand the data, which is relative to the business. Then doing the data preparation, doing the modeling of the data, evaluating the data, whether it is appropriate for deployment, and then finally deploy the data into the model and test the validation and accuracy of the model. Now, some of the automations in data science highly comes from, if you look at the points, we have automated bidding systems. I mean, we have some bots who are sitting at the backside of the program just to bid into a particular bidding system. We have high frequency trading, matching a Google AdWord with a user, returning high relevant results in a Google search, friend recommendations on Amazon. So Amazon, we know we get the section called as people who bought this also bought. So that is a recommendation system. Scoring the credit card transactions for fraud detections. I mean, this has happened a couple of times with me as well. So my credit card provider actually blocked my card when I was doing an international transaction, and that transaction was this. I think it was the frequency of that was 3 swipes. I think in a minute had happened due to some reason, and then the card provider actually blocked the card. That was actually the failure of the intelligence, but that's still that was into the pilot phase. So I'm sure that they have now done the accuracy of the model in a better way. So that is a fraud detection. We have some NASA taking up pictures of the galaxies and finding new planets out there. And it is also used for weather forecasts and many other situations. It is also used for in marketing for specialized targeted marketing. It is also used in cognitive services uh, for for listening, for speech recognition, for retina scanning, for thumb impression. So all these things come from automation in data science and artificial intelligence. Okay, so the next slide is talking about solving approach of data science. Guys, uh, there is a link mentioned down up in the slide that is retentionscience.com and how to approach a data science problem. And this particular blog is excellent. It has given a step-by-step approach on how to identify or a business problem and eventually what steps we should be taking to decide the solving approach towards it. Okay, so the first thing is the problem, understanding the problem. So discovering problems is which is very important. Then the analysis of the problem, prototyping of the problem, validation, development on that validation, testing the validations, and again redeployment, and then the supporting on those models. Now, what is this typically all about? Now, this is typically talking about the models, the recommendation system models. So we definitely the models would require training and would require certain corrections when it is running into the correctionized phase. So that's where the maintenance and the support comes into the picture. Um, so yes, you can take a note of this link, and I'm sure that you'll be able to, find out much better what are the different approaches towards the data science. Uh, the future of data science is the next slide. What we see on the screen. So the future of data science. What is the future of data science for us, for technology professionals, for statisticians, or for any other industry experts for that matter? So there is some text which I would like to read out. So the real change came with the combination of three situations. The first situation was interesting large data sets to make it worth the time and the energy and the work involved in working on those data sets. Second is the powerful computational capabilities like machine learning algorithms. And the third is powerful computers to actually process and operate on those algorithms, which are heavily pumped with large data sets. If you look at the image on the right hand side, we have the machine learning, and then machine learning has got three arms. So the first arm, which talks about, is the let's say unsupervised machine learning. On the right hand side, we have the supervised machine learning, and third one is the reinforcement learning. Now, the reinforcement learning is typically also involves cognitive learning, cognitive sense, like listening, uh, hearing, speaking. It all goes into reinforcement learning. Real-time decisions, driving a car with a selfless, non-driver cars, uh, which is also part of reinforcement learning. We have the game theories. Also, the artificial intelligence is used in game theories. The game theory, I'm sure you can Google about the game theory part, and it's very interesting when we talk about reinforcement learning. Robot navigation. So we have robots. We also have artificial robots who can speak with a human intelligently. When we talk about unsupervised machine learning, now unsupervised machine learning is basically when we talk about when there is no past history given about the data. There is absolutely no history given about the data. So that goes into the unsupervised learning. Supervised learning is typically when some information about the data is provided to the model. Some past information is provided to the model. That could be the past information could be under what conditions a particular product was sold in the history, and I want to now find out under what new conditions the product is likely to be sold in the future. So that's and but in the unsupervised learning, we have no clue about what was the history uh, and also there's a difference is in unsupervised learning we lack labels. So we really do not know whether customer is a rich customer or he's a poor customer or he's a regular customer. But in supervised learning, we'll definitely know. Basically, when we talk about classifications, we talk about supervised learnings. When we talk about clustering, we are talking about unsupervised learning. So you will know all this once you gain more hands-on into the program. I'm sure that it's going to be the learning science program. It's going to be very interesting. Moving on to the last slide, but not the least in the data science, we have the jobs and the career opportunities in data science. So data scientist salaries in India basically starts with almost 650,000 rupees per year, and in the United States, it's almost $120,000 per annum, and that's not bad, absolutely. So this means that it's worth investing the time and the effort learning a particular domain, and I'm sure it's going to be very interesting too, because data science is one area where we require logical reasoning. I mean, logic is the only thing which can work in this area in this domain, and analytical reasoning is something. And I'm sure that people who are not very great in analytical reasoning or logical reasoning, it's okay. I'm sure by learning the program that will give you an hint to improvise yourself in those areas. And also data interpretation is something which you can focus on. So here if you see what kind of job roles we have data analyst, we have quantitative analyst, we have data scientist. Now, some of the aviation companies, I just got to know that they are coming up with some job descriptions talking about pricing analysts. So aviation companies here in India, at least, talks about pricing analysts, and not only with the companies within the aviation industry, but any industry talking about the pricing. They're very price sensitive because consumer market is price sensitive. So any commodity is first judged by its price. So pricing analyst is one of the key requirements for the aviation companies by looking at the surge and the dip in the flight prices during the season and off season, etc. So they require specialists who can give the optimized pricing structure on the services and the products they offer. There is a question by Mohammed again, technical tools required by data scientists. So as such, it's up to you if you would like to practice and get your hands on to a technical tool. You can definitely choose any of the technical tools which has got script-based coding. Or in case if you just want to learn statistics, then Excel is something which you can live with. Mohit Khatri has a question. What about job role and data science for automation testing profile? So definitely, we have a huge opportunities for testing professionals, for automation testing professionals. If you are automating the scripts or the program using the testing techniques and approaches, definitely that can be automated using the data science. So you can definitely look at that part more. Rishi has a question on an average MNC, how many guys of data scientists we require. So Rishi, that's no set of count of people who are required. It purely depends on the client requirements. Hmm. Poorna has a question. Difficult to find a data science job as a new career due to no previous experience. So Poorna, I would encourage you to pick up an internship with the company. You can learn the program. Plus, you can do the internship with the company for approximately 6 months of time period, wherein you will be learning the techniques and methods to work on data science. So Mohammed says there's what is the initial role in data science? So initial role in data science could simply be working on the reporting tools, or simply be it in the MIS. Harishankar has a question. What about SAS? Is it advantages over R or Python program? Now, Harishankar, my suggestion would be to go with R or Python now, because most of the companies are trying to convert their SAS models to R or Python models because of the cost optimizations. Pooja has a question. Yeah, I have answered that, Puna. So Dhruvin Patel has a question for data science. Should I learn all tools? I mean, not necessarily, Dhruvin. You need not learn all the tools. You can just pick one tool because learning tools is not an issue. But mastering a particular tool would take years together. So I can learn Python in maybe 15 days of time, but in order to master that, I might take years together to do that. So be very sure about what tool you choose. Um, and also make sure that you do it well. There is a question by Mohit, for an experienced person, how easy, difficult to get a job in data science after changing his role profile? So Mohit, if you're good in logical reasoning, if you're good in qualitative analysis, if you're good in reporting, MIS, ag data, if you're good with the data, any part of the data, Mohit, it's not difficult for you to get a job. Mohit has a question again. Any suggestion for learning statistical models books? For learning statistical, I can recommend you a book that's called Statistics for Management, and that's written by Richard Levin and David Rubin. You can Google it right now. Statistics for Management by Richard Levin and David Rubin. Um, uh, this is the hands-on guide and also a field guide for me as far as statistics is concerned. Not much about the model is given. If you want to go for statistical model books, then you can go onto the Amazon books category section, and I'm sure that you'll definitely find good ones out there. But for statistics, you can definitely rely on this particular book. Thanks, Purna. Thanks for your time.
I'm sure you enjoyed learning from this video. Please like the video, and if you have any doubts regarding this video, please comment us in the comment section, and don't forget to subscribe to our channel for more such informative videos. Do look out for other related videos in our playlist. For more information, visit our website now. Keep learning with Intellipaat.